Okay, so this is just to go along with the lesson, the exact same lesson we're going to be doing in class. So I'm going to do my best to kind of walk you through this, but as always, I want to kind of go over the standard. Your standard is going to be to create equations in two or more variables to represent relationships between quantities, graph equations on coordinate axes with labels and scales. So let me find some of the other ones. There's some other ones in here I wanted to go over. Yeah. You're also trying to define appropriate units in context for purpose of descriptive modeling. So you're going to label axes accordingly and then choose a level of accuracy. I think this one's kind of loose. Maybe I'm wrong. But define appropriate units in context. So sometimes your scaling is going to be different. Yeah, choose a level of accuracy appropriate to limitations. That's actually true. So this first graph, what you'll see is that the y-axis counts by 5. Okay, so it's a little different than counting by ones, and it would be tedious to try and count by ones. So in math, we kind of strategize due to what the graph looks like. We want to fit the entire picture inside of the coordinate axis. Okay. Maybe we're going to get into modeling as well with the calculator. So I'm going to show you how to set up this exact thing in your graphing calculator if you kind of struggle with this. So, Professor Splash set the world record with a 36-foot belly flop into a 1-foot pool of water. So we kind of talked about this in the last lesson. And this is actually the equation, and it is physically correct. So there's some different components here. We can talk about them later, but I kind of want to mention this one. This one is due to acceleration, the acceleration of gravity, okay? So that number is not just being pulled out of the hat. A lot of these equations are going to look like this. So it's 1/2 the acceleration due to gravity, and then this is the initial height. So how far is he up in the air? Well, he's 36 feet up in the air. And the way I drew the picture might have been misleading, but I was thinking if he's diving, maybe he starts down here and kind of jumps. So that was my reasoning. But we are going to get into this. So is this on Edge? Oh, that's the packet, maybe. Okay. Can I play with it? Yeah, I can play with it. I'm good. Okay. So the first thing, you've got an input and output table. The first thing we want to go over is how to get the height from an input. So at 0 seconds, you can kind of see this from the graph. At 0 seconds, I'm 36 feet in the air. Okay. But you can also you can actually do this like inputs and outputs. So I'm going to start out with that. And this is the kind of thing I actually love. You kind of get into it, plugging and chugging, trying to find out things, solving the puzzles. So 0 is time, so I'm going to plug that in for t. So I've got 0 squared plus 36. So 0 squared is 0. 0 times negative 16 is 0. So I'm left with 0 plus 36. So 0 plus 36 is 36. And they're saying that the height is feet. So it's important to include the unit. So at 0 seconds, I am 36 feet in the air. And if you notice over here on this graph, that's on the y-axis. That's this point here. So that's also a key feature. Okay. So that tells us that the y-intercept is the coordinate 0, 36. Okay. So the next thing I want to plug in is 1/2. I want to see what happens whenever I plug in 1/2. So I've got h equals negative 16 times 1/2 squared plus 36. Whenever you square a fraction, whenever you raise a fraction to the second power, you're going to square the top and the bottom, so the numerator and the denominator. So I've got 1 to the second and 2 to the second. So I've got, all in all, negative 16 times 1 over 4 plus 36. So a half times a half, or square top, square bottom. This is what I'm going to get. And so if you take a look here, I've got negative 16 times 1 over 4. So I can write this as a fraction. Negative 16 times 1 is negative 16. 1 times 4 is 4. So this is the same as negative 16 over 4 plus 36. Well, negative 16 over 4, that's division. So 16 divided by 4 is 4. So negative 16 divided by 4 is negative 4. So I've got negative 4 plus 36, which is 32. So after 1/2 of a second, we are 32 feet in the air, okay? Or Professor Splash is. I don't know how he got his doctorate. That'd be an interesting doctorate. Okay. So the next thing we want to plug in is 1. So hopefully you're following along with that. I think I'm going to do 1 over here. So h equals negative 16 times 1 squared plus 36. Well, 1 squared is 1. So I've got really just 36 minus 16, because 1 times negative 16 is negative 16. So that's 36 minus 16, which is 20. So after 1 second, I'm 20 feet in the air. So we've looked at half a second, which we're right about there. So that's pretty good for 32 feet. And then what you'll notice is that as time goes on, Professor Splash is further down, okay? And right here is where he hits the bottom. That's where he hits the pool and the action happens. So I want to know the x-intercept and the point of intersection. Not exactly sure what they mean by point of intersection. So if you kind of look at the graph, kind of seems like 1.5 is where he's going to hit the x-axis. But we can actually do this with a calculator. So we're going to find that exact time. So let's get out that handy-dandy calculator. And I'm going to go to y equals. Well, first I'm going to set up my window. X min, I'm going to start time at 0. X max, I'm going to end time at 4. So if you take a look at that graph, the graph is telling me how far to go out. I've got 1, 2, 3. Actually, I could just leave it at 3. So I'm going to leave that at 3 instead of 4. So this is just allowing me to pretty much model the exact same way that they are doing it there. So y min is 0. So we're talking about the height. So the bottom height is 0. Y max is going to be 36, okay? So that's the highest point, and what you'll see is the graph is changing down there. It's because I've got something different plugged into y equals. So I'm just doing some scaling here. What you'll see is these little options here. You've got y scale and x scale. And if you take a look here, x scale, you're counting by ones, okay? So that's back to your standard. And let me just show you that. Back to that standard. Choose a level of accuracy appropriate to limitations on measurement when reporting quantities. We want to count on the x-axis by 1, okay? And then on the y-axis, we want to keep counting by 5. So we've got up 5, up 5, up 5. So the y scale on my graphing calculator is going to be 5. That's all I'm saying. So that tells the y-axis to count by 5s. And if you notice, my graph just changed. Each one of these tick marks means 5, okay? And then we're going to go into y equals, and we're going to type in exactly the same function, but instead of a t, we're going to use x. because the calculator by default understands X and Y. I'm sure there's a way to change it. Just kind of going for the nitty gritty. So negative 16x squared plus 36. That's how you type that in. And if I go to my graph, it's the exact same graph that I got over there. Yeah. And it, you know, the x-axis is just kind of perturbed out. If I had it end here, you'd kind of see the same thing. So maybe I should change the window so you can see that better. But if I do it like that, yeah, that looks a little better. Looks a little more like what's going on there. And what I want to do is I want to find the x-intercept. So I'm going to go to second trace, and I want to find a 0. So I'm going to press 2. So it's going to ask for a left bound. So what I'm going to do, he's really far over. Okay, there's my little guy. Okay. Left bound means you're going to go to the left of where that 0 is, where that function hits the x-axis. So it hits the x-axis down here. So if you take a look, my little cursor, my little guy, is to the left of that x-axis. So I'm going to press enter. So that tells the calculator to start searching for the 0 there. And then I'm going to move my cursor to just past where it hits the x-axis. So it's going to disappear out of reach. So you'll notice that the y value went negative. And then I'm going to hit my right bound. So what I'm doing is I'm telling the calculator, take a look at the values and see and just compare until you find 0. So between those two values, between 1.6 and just 1 over there, so 1 and 1.6, it's going to look for the value of where of x that makes the entire equation 0. So the next thing is it's going to say guess, and that just means the calculator is going to do that entire process. And there it is. So it tells us that 1.5, when we plug in 1.5, I get back 0. Okay, so that's the fraction 3 over 2. So I just want to show that. Over here, I'll do that over here. So if I plug in 3 over 2, I should get 0. So 3 over 2 squared plus 36. 3 squared is 9. 2 squared is 4. So I've got negative 16 divided by 4 plus 36. So negative 16 divided by 4 is negative 4. So I've got negative 4 times 9 plus 36. Negative 4 times 9 is negative 36. Plus 36 is going to be 0. So that just shows you that math works, right? When the time is 3 over 2, or 1.5 seconds, you get back 0 for the height. So that is the coordinate 1.50. And I guess the point of intersection, I'm going to have to look for that because I think they were mentioning something else. And then there's a few different graphs. So we're going to do some of these, but these are really fun to me. A submarine A is 900 feet deep and rises at 50 feet per minute. Okay? So that is 50x, or 50t. So let's do variables. So every minute, I'm going to add 50. Minus 900. So if you take a look, so this is D. So what you'll take a look at is some of those equations where we were modeling graphs. This is going to kind of come in handy. I know that the y-intercept is negative 900. I'm going to draw this in red. So this is negative 900. And every minute, I'm going to raise 50, okay? So I know that 1 minute, I'm going to be 50 up, And then at 2 minutes, I'm going to be 800. So every 2 minutes, I'm up 100 feet. And what this allows me to do is as time goes on, I know exactly where the height of that submarine is going to be. Yeah. My bad, my mistake. So as I'm talking about this, one thing you'll find out about me, my father, he kind of really loves submarines, so he might like this problem. So this is for you, Dad. Submarine B is on the surface level. So what is the surface level? Well, if this is negative 900, that means 900 feet below the surface. So the surface would be 0, okay? So submarine B is on the surface level and submerges 100 feet per minute, okay? So the surface level would be 0. So I'm going to start out at 0. I'm going to draw this in blue. So I actually have no y-intercept, or I can think of my y-intercept as 0. And this time my depth is going to start to go down. So I've got d equals negative 100t. Okay? So that means after 1 minute, I'm down 100. After 2 minutes, I'm down 100. So on and so forth. Okay. So over here, they're asking you to find particular points using the equation. 50 times 0, if I plug that into this equation. 50 times 0 is 0. 0 is negative 900. So that gives me that over here. When I plug in 0, I get back negative 900. But what if I plug in 2? Well, 2 times 50 is going to be 100. 100 minus 900 is going to be negative 800. And then again, if I plug in 4, I'm plugging in 4 for this t, for this first equation. And I get 4 times 50, which is 200. 200 minus 900 would be negative 700. So I'm over here down 700. For the blue line, they're asking me to plug in the points. So I'm going to do that. So if I plug in 0, I get back 0. So 0 times negative 100 is 0. If I plug in 2, I get negative 200. So that submarine is down after 2 minutes. It's down 200. You can kind of see that from the graph. If I plug in 4, I get back negative 400. So it's down, after 4 minutes, it's down 400. Point of intersection. What we're looking for is when the two submarines are at the same height. They're not at the same position necessarily. That would be bad, okay? If two submarines hit underwater, it might be over. But they're saying when are the two submarines at the same height? Well, if this one is at 0 and this one starts out at negative 900, this one's going up, this one's going down. So if you take a look here, the height reaches the same at negative 600, and that happens at 6. So essentially, if I plugged 6 into both of these equations, you'd see that their depth would be the same at the same time, okay? And I'm going to show that. So 50 times 6 minus 900 is equal to negative 600 feet. And if I plug in 6 into the other equation, I get d equals negative 100 times 6. So that is negative 600. So they're both at negative 600 feet at 6 minutes in. Okay? Past that, the first submarine's going up, 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 up. In the second submarine, he's going down to the Mariana Trench. Okay. And then we've got a few more of these to do. So, graph anything. To graph anything, and I'm going to really practice this with you guys. This is something that's going to be crucial. It's maybe going to be tough to start out with, but we are going to get through it. You can plug and chug. You can start to plug numbers in, see if they work. So the first thing we're going to plug in is -5. So over here in this equation, I've got y equals the square root of -5 plus 5 plus 1. Well, -5 plus 5 is 0. So I've got the square root of 0 plus 1. So square root of 0 is 0. So I've got 0 plus 1. So 0 plus 1 is 1. So -5 comma 1 is my first coordinate. Okay? My second coordinate comes from plugging -4 in. So I'm going to get rid of all that. And I'm going to rinse and repeat. Everywhere that I see an x in that equation, I'm going to plug in -4. I'm going to graph it. And what this is going to do is going to give me the shape of the graph from the points. So I've got the square root of -4 plus 5 plus 1. So -4 plus 5 is 1. So I've got the square root of 1 plus 1, which is 2. Right? Square root of 1 is 1. 1 plus 1 is 2. I hope. I hope it's still 2. Okay. Next thing I'm going to do is plug in -1. And the reason why they've chosen some of these points is so we get nice square roots. Okay? And you'll kind of see that. So if I plugged in -3, I wouldn't get a nice square root. I'd have to use my calculator. So I've got -1 goes in for x. So I've got -1 plus 5 plus 1 on the outside. So -1 plus 5 is 4. The square root of 4 plus 1. So I've got 2 plus 1, which is 3. So at -1, I'm up 3. Next thing I'm going to plug in is 0. So we get to rinse and repeat again. I'm just going to leave the equal signs. Go away. So I've got the square root of 0 plus 5 plus 1. Okay. So that gives me the square root of 5 plus 1. And from my calculator, this is where things get not so nice. I can type in square root of 5 plus 1 and see what I get. So I've got second square root 5 plus 1, enter, 3.23. Is what that gives me. So at 0, I'm up 3 1/4 roughly, right there. And that's what I'm talking about. These are the things you don't, you can use those. You can kind of think about it, but it's a little more harder whenever you're dealing with decimals, okay? You want to pick points that are kind of nice, but that'll work. That will work. Okay, the next thing I see here is 4, so I'm going to plug in 4. So again, we rinse and repeat. So I'm going to plug in 4. So I've got the square root of 4 plus 5 plus 1, which is the square root of 9 plus 1. Square root of 9 is 3 plus 1, so 4. So when I plug in 4, I get back 4. And we kind of want to just connect these with a smooth dot, and what you'll see is you get some sort of weird shape, and that is a type of square root function, okay? That is a square root function. We'll talk about shifting later. It has been shifted. I'm going to show you this in the calculator as well. The next thing they've got is -9. So I've got y equals the square root of -9 plus 5 plus 1, which is the square root of -4 plus 1. And you might be wondering, okay, well, the square root of 4 is 2. So the square root of negative 4 must be negative 2. Well, not quite. The definition of square root means you're literally looking for two numbers that multiply together, two of the same numbers that multiply together to be the inside of the square root. That is by definition what square root kind of does. And you can't achieve that with negatives. So negative 2 times negative 2 will not equal negative 4. It will equal positive 4. 2 times 2 will not work. So the square root of negative 4 is neither negative 2 nor 2. Okay? And if you come to your calculator and you beg it, please give me the square root of negative 4, it's going to yell at you. It's going to say error, non-real answers. So when you are plugging things correctly into functions and you get errors that say non-real answers, that just means that that number is not in what's called the domain of your function. It means you cannot plug it in, so you cannot get an output. So over here at negative 9, way over here, I cannot plug that point in, so I cannot see what this graph looks like there because it's an invalid input. Okay, same for negative 6. If I plug negative 6 in, I'd get a negative underneath the square root. Negative 7, I'd get a negative underneath the square root. So that's an invalid input. So it's said not to be in the domain. So even if I try and type this same equation into the calculator, that's all we're going to get, that part of the graph. It'll go on forever on the right-hand side, but it will not plot the other side. So I'm going to show you this. First, I'm going to change my window. So I'm going to plug in negative 8. And plug in 8. Same for y-min, negative 8. No, negative 8. 8. I'm going to change my scaling again. Oh. Y scale is going to be back to 1. If I go back to y equals, I'm going to clear this function out, and I want to see what this guy looks like. So square root of x plus 5 plus 1. I'm going to go back, second, square root x plus 5, get on the outside, plus 1. I'm going to graph it. And that's what he looks like. That's what that graph looks like. And if you can kind of see, I mean, maybe I'm not exactly perfect, but that's really stinking close to what's going on there. Something else to mention. Your calculator has this handy-dandy feature. So if you go to second graph, you'll see a table of values. And whatever you plug in for x should be the same thing that you see on the graph on this table over here for hours. So over here, I've got negative 5 as my first input. So if I go up to negative 5, you're going to see that same output. So negative 5, when I plug it in, I get back 1. For negative 4, I get back 2. For negative 3, I get back 2.4. And then I think there was 3.23 whenever I plugged in 0. Yeah, that was not nice. So I've got 3.2361. So if you need to see what the graph looks like, this is really helpful because you can do the input and the output together, and you can kind of see what the graph is going to look like. So it looks like that, and it looks gorgeous. I'm happy about that. So for this one, error. Okay. Almost done. We got one more little one to do. So I've got two different things. I've got time as my input, and it's measured in minutes. And then for my output, I've got quarters. And we're talking about the number of quarters, not the value. And the same thing over here. So time in minutes. and quarters, the number of them. So we've got Kat and Timmy, and let's kind of look at the story. Yeah, so Timmy and Kat are at the arcade. The graph shows each person's quarters over time. So how many quarters they used? Maybe. Yeah. So at time 0, we're going to look at Timmy. And I don't think they've labeled either one. Maybe they labeled it in their notes. So I'm just going to say that Timmy is blue. So we're going to call this one blue. So maybe their graph is going to be different. And then Kat is red. I'm going to have Kat be the red line. Okay? So at 0 seconds, I want to take a look here and see where Timmy is at. At 0 seconds, that's 30. So that is a y-intercept. So for Timmy, his y-intercept, it means Timmy has 30 quarters. At the start of his time at the arcade. Okay? Same thing for Kat. If you take a look here, she's got 40 quarters. 40 quarters. So at the start, Kat has 40 quarters. At the start of her time at the arcade. X-intercepts. If you take a look here, this is time, and the number of quarters is 0. So over here, this is when Kat runs out of quarters. And over here, this x-intercept, let's draw it in blue. This x-intercept, that's when Timmy runs out of quarters. So that's kind of what you're looking at. You're looking at the x-intercepts, the y-intercepts, and you're telling me what they mean. So I'm gonna trust that you know that Kat runs out of quarters at 16 minutes. And Timmy runs out of quarters at 24 minutes. So I'm not going to write that in there, okay? What I want to talk about is the point of intersection and what it means. So even though they're spending at different rates, and they start at different values and they end at different times, there is one time in the entire span of the 24 minutes where they have the exact same number of quarters, and that's what this means. After 8 minutes, Kat and Timmy have the same amount of quarters. Okay? So we are good with that. The only thing that's left to do is kind of fill these charts out and see where we're at. So I'm going to do that. So I'm going to look at Timmy's graph first, which is the blue line. I want to see where his value is after 4. So after 4 minutes, Timmy has 25 quarters. So he spent 5 quarters in 4 minutes. And then after 14 minutes, he's still going strong. He's somewhere between 10 and 15. So I'm going to say he's got 13 left, just above halfway. For Kat over here, she's got, after 4 minutes, she's got 30 quarters left. Let's change that to red. And after 14 minutes, she is just at 5, so she's been spending at a much faster rate than Timmy has. and you got some really, really nice graphs down here. You get to play with the graphing calculator, hopefully. We'll see how that goes. Plugging and chugging is going to be really helpful. You got some nice polynomials in here. I like it. All right, so I'm going to leave it at that, and I hope that helps. I know that was kind of a longer lesson, but we kind of needed to get into the nitty-gritty, so that helps. I will see you later.